Today we're going to talk about how to find areas under a normal distribution. So remember that most of the distributions we're going to be dealing with are going to be normal or pretty close to normal so that we can actually use a normal distribution to approximate probabilities. So the important thing to remember is that the area under any part of our normal distribution or any part of our normal curve is equal to the probability of the random variable falling within that region. So in other words, area is equal to probability. So that's the important thing to remember. The area is equal to probability. So area under a normal curve to the left of our specific value, x, of the random variable is equal to the probability that x is less than or equal to x. So area to the left is going to be less than or equal to. So this shaded region, if this is my x, little x, this is the probability that the random variable x is less than or equal to the value of little x. Similarly, area to our right of a normal distribution is equal to the probability that x is larger than or equal to the value of little x. So area to the left is going to be less than or equal to. Area to the right is greater than or equal to. So what we don't talk about is the probability that x is equal to a specific value because of the fact our normal distribution is a continuous probability distribution. So if you think about finding area underneath at one specific value, so let's just say I want to find it at this value x. So you can think of it as approximating this by a rectangle that's as wide as the interval you're looking at. So if this is just going from x to x, right, and we're approximating this as a rectangle, our width is just going to be x minus x, which is 0. And then our height is going to be whatever the height of the normal curve is here. But if you think about approximating this area as a rectangle, well, it's going to be 0 times, so the area at one point x is just equal to 0 times our height, whatever that height is, call it h, but 0 times anything is 0. If we think of it as approximating it by the width of a rectangle and height of a rectangle. So the area at any one point itself is going to be 0. And so we can't find probability at a specific value. We have to look at probabilities for a normal distribution on some range of values. So we have to have a range of values. And so we either can or don't have to include our endpoints. So you can say probability for a continuous distribution, the probability x less than or equal to little x is equal to the probability that x is just strictly less than little x. Now keep in mind, this only applies to a continuous random variable. So if we're talking about a binomial, you still have to account for that and get the equality first. But for a continuous, you don't have to worry about equality. So this is only true, though, for continuous random variables. That we don't have to worry about the equality. So we need to be able to calculate area under a normal curve in any of the given regions. So you can do this using integration. That's in calculus, though. That's beyond the scope of our course. So don't worry about that. Another thing that makes this difficult, if you're trying to do this by hand, is the fact that there are an infinite number of normal distributions. I said that the other day, but there are an infinite number of normal curves. So we would have to actually, if we wanted to find the area for any normal distribution, we would have to do this for every single normal distribution that exists, if you're doing it by hand. Now, for the standard normal distribution, so remember this is also the z distribution. So remember this is just a normal distribution where mean is equal to 0, and standard deviation is equal to 1. So area under this normal distribution, this special one, it's fixed. And these tables have already been created so that we can find those areas. So we don't have to do the calculus. The calculus has already been done for you. You can also find this using calculators, some statistical software. So SAS can do this, Excel can do this. But for our purposes, you really just need to know how to do this using those tables. So focus on the tables. Your book is going to mention how to do this in your calculator. Don't worry about it. Don't let that confuse you. So the way we're going to do it is we're going to find the area using the standard distribution tables. So for us, these tables are going to be Table A and Table B. They're in Appendix A in your textbook. They're also in the back of your course pack. So they're in your textbook or course pack. And these are the tables that we're going to use. And so these tables are always going to give you the area to the left of your z-value. So whatever your z-value is, so if this is our z distribution, whatever that z-value that you have is, your table, the normal table in the back of your book, will always give you the area to the left. So remember, it's going to give you the probability that z is less than or equal to some value of z. That's what the table in the back of your book is going to give you. So the way this table works, and this is just from Table B, so the difference between Table A is z values less than 0. Table B, z-scores greater than 0. So to use this table, we want all of our z-scores to be 2 decimal places. And so we work down this left-hand column, and our left-hand column is going to give you the ones digit and the tenths digit of that z-score. The column across the top is going to give you the hundredths digit of the z-score, so the second decimal place. So for example, say my z-score is equal to 0.62. Then I'm going to go across, on the first column, I'm going to go down to 0.6. And then I'm going to go up on the top to 0.02. And so where that row and that column intersect, so I'll just go across until they intersect, that is my area to the left. So the probability, because remember area is probability, so the probability that z is less than or equal to 0.62 then is equal to, in this case, 0.7324. And you should always keep all of the digits the table is giving you. So these tables have already rounded everything for you to the 4th decimal place. So you want to keep those digits, all of the digits the table gives you. So let's look at another example. So let's find the cumulative area corresponding to a z-score of 1.15. So same idea. We're going to go down to 1.1. And then we're going to go down across the top to 0.05. And we're going to find where that row and column meet. In this case, it's 0.8749. So the area to the left of z equaling 1.15 is 0.8749. Or remember, this is the same thing as saying the probability that z is less than or equal to 1.15 is 0.8749. So go ahead and try this next one on your own. So try to find the cumulative area corresponding to a z-score of negative 0.24. So same idea. We go down our first column, and in this case it's going to be on table A because it's a negative value. So go to negative 0.2. Go across the top row to 0.04 and follow to where that row and column intersect, and you get 0.4052. So that's our area to the left. Or remember, this is the same thing as saying probability that z is less than or equal to negative 0.24 is 0.4052.